Okay, good morning, everyone. Welcome to our webinar today. We're just going to give it 2 more seconds and then we'll start. Okay, thank you very much, everyone that has joined us today. Today is, I think, the 5th in our series of workshops that we've been doing in this InFocus webinar series, and it's really been very exciting for us to be involved in this. My name is Simon Bromfield. I am the project lead for water at Modena, as well as some other projects, but mainly water is the big focus of my life. With me today, I have Jason. Jason is a civil engineer by training, but he's also very passionate about water and he's put a lot of information together for you today. Jason, do you want to just give some opening comments before we start?
No, fantastic. Thanks for having me. Yeah, today is going to be quite a fun one. What we're actually looking to have a discussion on today is changing up the game a bit. How can we start looking at changing up our design and where the future of design is actually going with regards to stormwater? So it's going to be quite a fun one. It's going to be a good one.
Yeah, it's been really interesting. I think, if you look at what's happening in South Africa today, there's been a lot of information about water. I'm really interested to hear your feedback on this. Just for the participants here today, we have a special offer for you. So for joining our call today, we're actually offering you a discount on our software. You need to stay till the end. There's some stuff that we need you to do to get it. So please hang around with us for the presentation. And it's really going to be worth your while at the close today when we get there. So let's talk about what South Africa is dealing with today. I'll hand over to you, Jason. What are your thoughts on this? What are you thinking about?
Great. So what I was thinking about is let's actually start look at what are we dealing with, what are we actually working with, because this is obviously going to then move over into what we can actually start looking at and fixing. Now, as we look at the country as a whole, we know we've got such a variety of climates and ecosystems that are happening. If we go from the Eastern Cape all the way through to the West and even up to the North, we have so many different ecosystems taking place that when we look at a concept of design, it is actually going to be dependent on which ecosystem we are working within, because that's going to require different solutions because we have different challenges in those specific areas. Now, generally, if we look at stormwater as a whole, we have our national precipitation is half of the global average. So it's not that we're actually sitting in this extreme weather conditions that we need to be going into the extremes of bad or drought or for flooding. So we have actually got a good middle ground where we are working within, where we actually have freedom to move, where we don't have the high extremes or the lows that cause more technical challenges to the solutions. So that is what we are now looking to actually get a more consistent water provision throughout the year.
Yeah, it's interesting that you say that, because if you speak to a Cape Townian today, they're drowning. I mean, they've got so much rain this week, it's frightening. I was looking at on TikTok this morning, whole Pinelands is underwater, and we've seen these major storm events that we've seen, like in Durban and the Eastern Cape, the Bishu Dam overflowing. But are these really uncharacteristic flood events, or are they just things that we just haven't seen in our time? Because if you look at South Africa, we've only been collecting data for less than 50 years in those areas. So, when we talk about a 100-year floodline, what is a 100-year floodline? If we've only got 75 years of data, even 25 years of data, how do we even calculate that? And I think that's some of the context that when we're thinking of water in South Africa, that we really need to look at.
Definitely, because exactly to that point is a lot of these have been predictions and based off statistics. We don't have these extreme weather conditions, and the only reason that we are starting to get these is because of this climate change that we're seeing to happen, the shift taking place. I mean, our seasons are shifting throughout the year, and the intensity of these rainfall and droughts is increasing and decreasing in either way, depending on the situation. Like the floods in KZN, but then also a few years back, talking about Cape Town as well, where they had the biggest water restrictions in the country. So, we're playing on both sides, and that is, I think, one of the main challenges that as South African context that we need to manage is having the longer vision of being able to cater for these extremes as we predict these changes taking place.
Yeah, it was quite interesting. I mean, in the stats that you see, we've highlighted here, only 8 to 9% of the water is actually being used. And that's a major thing. We're talking about, the Vaal In the last couple of months, we've seen the Vol running at 600 cubic meters per second.
Yeah.
It's just wasted.
Yeah.
There's no holding back. The Vol dam was at 128%, and they're just releasing the water.
Yeah.
No.
Because we don't have the infrastructure further downstream to allow us to disperse that load and the vast amounts that we are dealing with.
Yeah, so it's going to be very interesting. So let's talk about some of the obstacles to the flow and some of the challenges. Let's go a little bit deeper into it and some of the things you've seen, Jason, in the work that you've done.
Definitely. So the first thing that I was looking at is the growth and development that's currently taking place within our economy, which is fantastic. We need this. The country is growing at a fast rate. But with this development, obviously comes impervious cover, which is point number one. So as we look into the sustainable design, we need to start at point one. It doesn't help that we look at how we are currently working with current infrastructure design and just trying to change that midway through the process. We need to be starting a lot earlier.
So for a dumb person like myself, what does impervious cover mean?
Great question. All right. So just the impervious cover is referring to any surface that gets closed off where water cannot penetrate and actually perviously drain through that substance. So that will be looking at our roadways, your concrete, parking areas, your sidewalks, all of those where
tops.
Correct. Yeah. So we have this water that's actually falling down, but it doesn't directly fall in and saturate into the soils back naturally where it falls.
And that's what's causing the massive runoff events that we've got, because the water is not going anywhere.
Correct.
It's literally running straight into the stormwater.
Correct. And like we all know within the country itself, there is a lot of old infrastructure that needs to be revitalized and upgraded. So now with this development that's growing exponentially, that tends to lack a little bit, where we expect existing infrastructure to function like it does. And a lot of the infrastructure in our country at the moment is working anywhere between 70 to 50% capacity, where to what it was designed, it's not actually functioning correctly. So I think that's point number one. The less impervious cover we can develop and create, that's already reducing the problem from step one. So,
and how would you go about doing that? What did you look at? I know we're going to talk a little bit about this, but what are the things you'd be looking at in your design?
So that would be where we start looking at how can we actually start changing the materials being used, as well as then how that area is actually being utilized. So for example, one of the biggest ones that we can actually look at for South Africa as a whole is the permeable paving, whereby we still give allocation for that space that needs to be utilized, but now we're applying a dual purpose to that, where it's functioning as a parking area first off, but that parking still allows us to saturate and get that water imperviate and implement it and saturate it into the soils. And then below that, we have a larger area to once again work with that water. So we're not concentrating it into these focal points.
Okay. Then you spoke about infrastructure constraints and pollution. I think those two are sort of linked together.
Correct, yes. Because, the pollution has an effect on the infrastructure itself. And that is where, once again, we need to look at the bigger picture of pollutants is one of the major factors that is currently stopping our infrastructure from functioning what it should be. This is silly things like blocked drains, your silted pipes, and things like that. So we need to keep that in mind when we are starting to look at what are we going to do for these solutions, because that will have one of the largest impacts on those solutions.
So when we're talking about pollutions, we're not just talking about sewage and chemical runoff, we're actually talking about things that are not meant to be in that pipe that are being put into that pipe.
Correct, literally like a small little chips packet. That is, from my site experience, a chips packet is the worst thing that you can have, because it's so small, it's so light, the water picks up and it goes through, but as soon as it tears, it opens up and it has such a large surface area that any orifice that the water needs to be going through for a throttle control, any type of drainage points, those get clogged up. A simple Coke bottle, stuff like that, it's those small things that have such a big impact that we need to be working around, and makes design 3 times more difficult.
You'll remind me when I speak to my wife tonight, because she loves chips, so I'm going to tell her that.
Yeah, no, let's try to avoid those as much as possible.
Okay, then of course political. We're in GNU at the moment, and we have all of these political constraints. I think from a political perspective, we had good policies in place. We had good water policies. Today, many of our municipalities do not have a master plan for water. That's correct. Yeah. And this is something that government needs to put in place, but it's also things that industry needs to look at. And if I think about political in South Africa, if we look at BIM, for instance, there's this whole talk about who needs to go and implement BIM. Is it the companies or the government? Where does it come from? And we found where BIM has been successfully implemented is at a company level. So yes, we have political issues, but that doesn't stop our customers and our consumers actually starting to adopt the technology. And that's a very important part of it. Is there anything else you want to add on the political side?
So from the political side, yeah. So another thing that we need to keep in mind is that the regulations that we are working with, because we want to start looking at changing designs, it obviously changes how we incorporate different elements together with one another. And that's going to be, to a certain extent, regulations and permits that are going to be limiting us on those effects. So that is something that we need to start looking at. And great, like you mentioned, I think with regards to the companies being the ones with these implementations, that is going to be like that, because government needs to be able to have their assurance and trust that these processes actually function the way they're supposed to.
Yeah.
So I think they'd rather let that go to the private sector, have them make sure and get it functioning and running properly, and then they'll implement it from there. So we need to be the spearheads.
Yeah. It's quite funny, when people always say to me that the challenges we have in Africa are so big and we've got all these problems. But I don't know if you've been reading about the Thames Water issue.
No.
So Thames Water is the outsourced part company that looks after all the water that is around the Thames River basin. And they're putting in the same amount of sewage into the Thames that we are putting into the Yellowstone.
That is ridiculous.
Yeah. So we're not as bad. I mean, if you look internationally, they have the same problems that we have, and they're trying to address them. And Thames Water, if you follow anything on the BBC, you'll go look at anything in the UK. It's a massive, massive challenge for them, and it's really becoming something that a lot of countries are taking up. Last week, the river, I forget the name of the river in Berlin, they had their first ever open water swim in that river. First time ever anyone's ever been on the swim. I mean, they put a law in, I think it was 1861, they banned swimming in that river. Wow. 1861, and last week was the first time that you could have an official swim in the river.
Was that due to pollutants and all of those environmental factors?
Yeah, there's environmental factors. So the amount of work that they put in and utilizing proactive design has now cleaned that river to the point that people can now start using it again, which is an incredible story and something that I was following this week on social media.
Sure.
So let's talk about, what can we do around the utilization of proactive design? What can we do to make things better?
There we go. Yeah, I love this picture. This is one of the first pictures that I saw that I was like, this is where we need to be working to. And this picture on its own, so I just want to take a moment here. This gives us a good understanding of what we are looking to achieve. And here we can really start looking at a few possible problems. So I'd also like to give this out to the audience and try and see if you can spot anything that, makes you a bit uncomfortable. It's like, how would that actually work? I was lying in bed last night and I had the idea. I was thinking about there on the far left, you'll actually be able to see the swale channels, the swale designs. And I thought something like that, it's quite nice to be able to have a channel right next to the road. But then we sit with other problems like, now that we've got the saturated soil, how's that going to affect the road layer works? Yeah. So this, we're going from one step to the next, and it's quite fun to start looking at how we can get these implemented.
And it's all interconnected.
That's correct.
Because you can't do one without touching the other. That's why, I think software plays such an important role. If you've got the right software tools that are able to integrate all of these functions, you're able to see the knock-on effect. And we talk a lot in previous presentations around upstream and downstream of the work that you're doing. What is the impact?
There we go.
And this is very important from that side. Yeah, so I'd love to be able to see this. This irrigation for the trees in the middle, that's quite clever as well.
Right, and it's so simple, but it's, once again, it allows and opens up space for just something as basic as attenuation, where we don't need to be dealing with this massive water right now. If I can slow that down a little bit and have it in a more manageable bite-sized portion, that allows me to then have better infrastructure in the surrounding areas.
Yeah, cool.
So that's something definitely we should look at.
Okay, then let's look at the challenges now. You've got a whole lot of acronyms here.
There we go.
You are going to have to explain these to people, especially to me, because I have no clue what a SUD is and what a WAD is and all these things. But let's start with water sensitive urban design.
There we go. Yeah. So like Simon mentioned, these are just acronyms within the industry. So many of these industries are actually technically country specific, whereas they've started looking at sustainable design, that they've come up with their own phrases. So like with regards to the WSUD, that's actually an Australian-based terminology, and they refer to it as the water sensitive urban design. So What the W study is actually looking at is a holistic overview. So this is where we are looking at stormwater within all the other disciplines and how does it fall within the project itself.
Okay.
So we're not going into any details at the moment. Project location is what we're looking at. How does the building that is going to be built fit onto the site?
Yes.
And how does that intertwine with the stormwater elements, your drainage ponds or a bioretention dam or stuff like that?
And this is more green, correct? This is like thinking of how to green a city.
Correct, yeah.
And I know that Autodesk has been investing a lot of money in this at the moment. And if we look at the new direction that they've taken with InfoDrainage and all the technologies, this was a big focus for them as well. How do you start building in your water sensitive urban design so that you can manage green water?
That's correct, yeah. Because, like, once again, with the holistic framework that we're trying to aim at, is I'm glad you mentioned Autodesk because we're all looking to go to sustainability and reduce our carbon footprint. And this is exactly the first step towards that within the infrastructure side of how can we reduce the carbon footprint of that infrastructure by incorporating it back into the natural habitat. How can we bring design and nature back into our infrastructure? Because if we don't create the problem the first hand, we don't need to solve it. And if we can get that blend working together and get multifunctional operations and parts within the design working together, we're just making our own life easier from step one.
No, absolutely. And that, I think, is very important. And then the next one is SUDS, which most people know about.
That's correct,
That's what we've been carrying on at the moment. So talk about SUDS and where do you think this would come into our systems?
So this is now as we start going further into a little bit more detail. So SUDS is what we are actually looking at, the physical implementations and the physical processes that we have available to start actually utilizing and implementing this into that. So this is where we start looking at, once again, taking the large body of water and breaking it down into multiple stages, where we'll start off with a bioretention dam that then leaks and trades off into a swale. So we're just increasing the filtration rate that the water takes place in and is actually being utilized within that element. Even with the green garden or green roofs is a good example, where we'll have vegetation on these rooftops where the vegetation itself then absorbs this water and also slows it before we actually then output it again to a transportation.
So it's no longer just putting in a big pipe and shunting as much water off the side as possible.
Exactly. That's what we're trying to move away from, because that's exactly what's causing the problem. We've caused the problem earlier up in the line, so now we need to transport that away, and that's what we're looking to move away from.
It reminds me of the phrase they use in waste management, which is called NIMBY. Not in my backyard. So as long as it's not on my property and it's affecting someone else, it's okay.
Yeah.
But that's not true anymore. You have to be able to manage your water.
That's exactly that.
Low impact design, I think this is self-explanatory, but maybe just chat a little bit more about that.
Yes, exactly that. So this is where we actually start utilizing SUDS in a specific method. So I was actually reading this, and it's quite a funny phrase. Is one of the phrases they use is evapotranspiration. Which, you know, it's a mouthful, but
maybe we can actually ask on the chat. Who knows what that means?
Oh, that's actually fantastic. Yeah, let's get a bit of feedback. And so, yeah, who actually knows what evapotranspiration is actually?
What does it mean?
Yeah, what is it?
Yeah.
So, but
because when you told me this morning, I had no clue. But I sort of worked it out. It's got something to do with vapor and movement, but I wasn't quite sure.
Yeah.
So yeah,
it's close enough. Sorry, but while we just give the audience a chance just to get some feedback on that, I just want to finalize and also just get back to the low impact design. Is the main impact or the main idea that we're looking for with a LED or the low impact designs is slowing that water down to actually get the infiltration of the water back into the soil. Okay. So where the main principle is to try and get where it lands is where it stays. Okay. We want to try and transport the water as little as possible so that once we actually get that water on site, that we still make sure that we keep that environment in the area as healthy and natural as possible.
Yeah, I think, and that's, you know, when we talk about groundwater usage and all of that, it's important that you capture water in the ground that you're actually using, that you're drawing it from. So that's important.
Yeah, I mean, fantastic. Like we saw earlier, 89% of our water is just coming from perspiration. But that's a fun fact. More than 20% of water used, potable water used within the country, actually comes from groundwater. our boreholes and stuff like that. So that is a major thing. So within our country, it's actually very important if we can actually start saturating those soils again to get those underground aquifers filled up
That's
back
a
to what
very,
they need
very
to
valid
be.
point. So, I mean, that's something that we need to be focusing on, and we can see it, with some of the aquifers actually running dry in some of the areas, and massive aquifers that they found in the Western Cape. So there's a lot of business there.
I mean, how many rural areas actually depend on those aquifers as well, where they've actually had to go drill boreholes and tap standpipes in for rural areas, because that is the only feasible way of actually getting potable water to them most effectively.
Yeah.
So that's a big thing.
Very important. So everyone is very scared of the word.
Oh no.
So no one has given us feedback. So do you mind just explaining what it means?
All right. So it's actually not as complicated as what everyone thinks it is. Evapotranspiration is literally just transporting water through evaporation.
Okay.
So literally picking it up over here through the clouds, dropping it off over there. That's what we're looking at.
And in design, is there a way to do that in design? Can you actually now?
Yeah. So that is literally what we're trying to achieve with that is just attenuate the water for as long as possible, get it baking in the sun, and the longer it stands there, then obviously evaporation will do its job. So that is pretty much one of the design elements we can keep in mind. So that's where we'll look at maybe a bioretention pond or dam. So, we'll have it a workable play area. You'll still have your safety side slopes, so that you can actually make it a park when you have your dry seasons. And then in the floody wet seasons, obviously the kids won't be outside, they'll be at home. Yeah. And we can actually then utilize that as a dual purpose, as a bioretention dam. And then as we actually have water stored in there, it then becomes a little pond for people to go walk around and go admire. And you might have ducks or stuff coming in. So that's the main thing with that, yes.
Okay, cool. Then triple bottom line. It sounds a bit like the yeah. Explain this one to me.
Fantastic. So this is just giving us the scope work or the backbone of why we are doing this.
Okay.
And this is broken down into three main elements. Okay. So the first is going to be the environmental, the sustainability, which is why we're doing all of this. Now, as we look at the environmental factors, that obviously has an effect on the social economical factors of the people using it and the infrastructure around it. And then obviously the social then leads into the economical. So these are the backbones of what we are aiming to solve. We have environmental problems like we know with the global warming and change of seasons. So this is the main reason why we're doing all of this. Secondly is the people. We are designing for our community, for ourselves, and how we utilize this infrastructure. And the better we become as people and the happier we are as people, that obviously then moves over to the economy. So that is what the triple bottom line is going down to, is why we are doing this, how we are doing it, and for what are we doing this.
So as a business owner, bottom line to me is a number that I can calculate. Is it possible that we can start to calculate the return on investment from these things?
Oh, definitely. Okay. We'll just need to do the right breakdowns and stuff like that. But we are able to literally go and take it from a project aspect, even down into a software aspect, and even as a utilization aspect or a workflow aspect. We can break those elements down into measurable factors.
Yeah, because that's what businesses want. They want to be able to say, I've done this return, I've got my carbon tax offset. This is very important for the new ecosystems or the new economics of where we're going.
Being able to take that feeling and actually quantify it into a black and white value.
Yeah, always important.
I get you.
So we've spoken about this, we've spoken about how it affects other countries, but how does it fit into South Africa?
And this is where I now wanted to start challenging the audience a bit.
Yeah.
And, that's also why I took a moment to look at the picture earlier, is because we've now started looking at the information. What are we dealing with? What is today's discussion about? And this is why I now want to start challenging the audience, is to start thinking about how could this actually be implemented? Because we've seen all these wonderful things being done across, like you mentioned, the UK, within Australia. But, we have our own challenges that we saw earlier. So one of the main ones is, how would swale channel be implemented onto a major arterial road, like a highway? I was speaking to one of my colleagues this morning, and I mean, imagine being able to drive on a highway and you just have this luscious environment around you. Your stress levels will go down because everything's nice and green. You'll see all the little pretty flowers. But at the moment, we've got all these concrete channels and linings, and it becomes very industrial. And I think that is something that we need to look at, because, like I mentioned earlier, with regards to the saturated soil now, with regards to the road layer works, how are those two going to be working together? Because there are going to be construction limitations we might be running into. Because the layer works might start eroding away because we have so much saturation. So this is what I want the guys to start thinking about, is how can we actually start implementing this in our current designs and then improve on that in the future?
Yeah, no, it's very interesting because every time I think when you mention this, all I can think of is just for the background for everyone, Jason and I spent some time in Spain last year, Barcelona, and there were two streets. There was Los Romulus, and then there was a street at the top. And Los Romulus was this old school, very concrete, lots of paving, nowhere for water to go.
Yeah.
And then the other road, and I forget what its name was, the one at the top, had been greenified. It had the green belt, it had the trees, it had the water flow down the side. And it was just such a better experience.
Yeah.
And I mean, it was in the same city, but what a difference in terms of cities,
yeah.
in terms of roads and infrastructure. And you could see that they'd taken a a green first approach when they built that other section, because they'd integrated all of the natural areas, and you could see there was a running path, there was a bicycle path, there was a tram, and it worked.
Yes,
it was really nice. You didn't feel clustered. There were trees everywhere. It was a really good experience. And if we could bring that into South Africa, that'd be amazing.
Yeah. Just to make you think back a little bit, good now that you mentioned that, do you remember after the conference on the one day we were walking home and it was pouring with rain, and our hotel was actually quite close to Los Ramblas, but we actually walked past that, and I don't know if you actually noticed it, but when we were in the greener section, the water flowing on the surface was a lot lower than what we got to Los Ramblas. We had to dodge a lot bigger puddles and river little channels going down, and that's exactly what we're trying to avoid. Yeah,
I felt like a drunk person walking down the road because there's so much water just standing everywhere.
Yes.
That you're just getting sopping wet. And when we were in the green section, it was beautiful. There was nothing.
Yeah, you could actually walk there quite efficiently, you don't have to worry about getting your shoes wet and all that. Yeah.
Cool. So I think that's, these are things that we could implement here in South Africa. So you're talking about swale and where, swales would look and how we could implement that design. We have some major road networks that are being built at the moment. That could be really interesting.
I mean, like thinking about it now, I know the R21, they've got this express route that they're busy working on. How would that look like comparing the standard arterial route for the roads and now the express route they want to do for the truckers? Actually implementing green design there. For the truck drivers that are doing long routes, I'm pretty sure they are going to be the first people that actually see the benefits of having a nicer area to drive in and stuff like that. But it's also going to make it safer for them.
Absolutely.
And another question that I actually found quite fascinating when I was thinking about it is, are our buildings structurally ready for green roofs if we were to go that route? Because now we've got additional weight that we are placing on the structure that a lot of people don't think about. I mean, I've seen it on the Gautrain driving here into Sandton. Yes. There is just off the Midrand, there's a building that's got a massive water tower on top of it. And it got me thinking is like, was that placed there when they designed the building and actually accounted for? Or was the building manager now just thinking, oh, a fantastic idea, we can store water for when there's no water, water shortages and stuff like that.
Yeah.
And is the building actually capable of carrying that weight on the roof?
That's a very interesting design with all the buildings we've had collapse issues and making sure that when we're building something, we're thinking about things like this. It's really important.
Yeah. Because the green roofs is one of those that will help us for our water shortages. Yeah. When we have this Rand water with a reservoir that's run empty, if we have green storage at the top, whether it be through your infiltration beds or stuff like that, it might not be potable water, but you can at least still flush the toilet. You can still be a bit of a human and still have a bit of a living household type of thing.
Just a joke on that is this week, I mean, I've had no water at home.
Oh, no.
And it's because, we had the company next door to us actually put their fire suppression unit on, and they drained the reservoir.
Oh.
And because of lack of planning, they didn't think about it. And these guys, when I laughed at, these guys have a boreholes. So why did they connect it to our network? Why didn't they just use their borehole water? And those are the types of things that we can use borehole in green roofs. We can actually address a lot of the problems that we've got. And, as we're going forward,
put the space for it.
If we look at how electricity prices are going up, putting in green water functions to handle grey water within green water would be a good way to start looking at it.
Yeah, it's exactly that. So that's it's a massive thing to be looking at. Now that you even mentioned the grey water and the effluent water, there's actually Century City in Cape Town. Was also there we go. It's fantastic where 80% of the irrigation water come from effluent water, where they've actually been able to treat that within their bioretention dams and filter all of the nonsense out and use that naturally, lowering electricity costs, transportation costs to get everything there to and from. So we can once again reuse this infrastructure for more than one purpose.
Yeah, I think it's a really interesting use, and I think green roofs is something that's going to become more and more important as we're going forward.
Mm.
You know, there are some, if I think about it, there's some in the mid-range, in the Gulliesburg, there are some places that have done it. I
There's
think it
a
is
few
more
buildings, I know about 2 buildings in Joburg CBD that have implemented that and started with it. Yeah, so it's slowly getting there, but I think we just need to just get the message out there.
that
Make
it's
it
possible. Yeah.
Yeah,
And then, of course, you know, we talk about reducing the amount of impermeable surfaces for runoff design. I mean, that's a given.
that's
We've
correct.
got to do it.
Yeah,
And the tools are there for us now to be able to use it. So the software can help us to simulate this. And this is where, you know, software starts to play such a big role.
yes, because the software allows us to actually have these, I love the word optioneering, where, like you mentioned earlier, is because everything is so integrated with one another, that when I start implementing one change, I want to be able to have an analysis or look at the picture once again in the holistic overview, and does it actually work together?
Yeah.
And then be able to say, oh, no, it doesn't. So instead of now removing all of that information, starting from scratch, I can still then save as or create a different option and then take my design from there again. So should I need to fall back on it, that I have these iterations, that I'm not just replicating work over and over again.
Yeah, because there's actually a white paper that we'll give you guys afterwards that's a future-looking thing around AI in water. And there's a lot of that concept in it's around optioneering, because we can do it already, but AI can help us a little bit better and give us a little bit more. And I know that that is really a future-looking document, but there are some very good threads in there around where we can start using AI to augment our current work.
I think it's a good word, yeah.
So it's not going to replace what we're doing, just going to give us more options.
Yeah, because it's there to make our life easier. We're trying to just gain efficiency. Efficiency is the name of the game within our industry. Yeah. And the better your efficiency is, the better your end result is.
Yeah,
that's basically what it is.
Yeah. Then we talk about, you know, how do we incorporate WASODs into our current spatial planning zone?
Yes. So that is, though, once again, coming back to those political aspects.
Yeah.
And, you know, how does our planning and permission, like with regards to these guys that now are connected illegally, if they had followed the right regulations, got the right permits, they would have had someone with the right knowledge to be able to guide them correctly. To say, but guys, you don't know what impact you're having on the system.
Yeah.
You're not going to cause such major backlog and drainage of the system that it's causing more damage to get it rectified to where it was, just by then just doing your paperwork and getting the right permits.
Well, the joke is, now that they've filled up their tanks, we've burst nearly every pipe in our area. Because by putting the water back in, because there's no water pressure, all the pipes have collapsed.
Yep.
And now they put pressure back in, and all the pipes are popping.
And all those joints, those anchor blocks are just not happening.
Just not happening. So I mean, these are things that we need to look at, and I think in South Africa we do a lot of estate planning, and we do a lot of township developments where guys are building estates, and that's where this could really play a good role for us. You know, if we're doing another Centurion area, or we're building another golf course with houses around it, these are really cool places that we can start implementing this and start using it to really create spaces that are probably more efficient.
Definitely. And with that being said, is then the software even allows us to have that global holistic overview for the master planning. Like you mentioned, like a lot of the municipalities don't have that, because I think that's, once again, we are at the moment developing in such puzzle pieces that we're just fitting in the little spaces, and we're struggling to have the bigger picture of what is the effect having on our neighbors as each of these pop up and on the global major system. And I think that also just needs to be revisited to a certain point, just so that we have a better understanding of what we are working with, so that we understand how to grow it correctly.
Absolutely.
That's a big thing there.
Cool. Then let's talk about making the most of design. I think that's why we're here today. We design people, and that's where we focus. So talk about the cohabitation through design. What your thoughts are there?
Yes. All right. So, yeah, like you said, we're looking at all these problems, but what is the solution? What is the actual change that we can start bringing and actually looking at this? So, once again, it comes back pretty much to our SUD explanation of how we are trying to take stormwater management systems and infrastructure and phasing it over multiple stages, because that lessens the load on each stage individually, but then also making it a workable environment, whereby you can actually walk over a nice little pier that is being utilized as a bioretention dam. So getting back to the core principles of allowing the SUDs to do its job.
Yes.
So that we can actually utilize and actually see these changes happening. But now, with that being said, there's being responsible once again with pollution elements and stuff like that. So with all of these new things, we also need to be able to protect the function of it, because not everyone is aware of this at the moment and how they function.
Yeah.
And as a society, we just need to train everyone and teach them what these are.
Yeah, I mean, it's not the focus of today's discussion, but we've talked about pollution control and how to track where pollutants are coming into water networks. And there are such good tools now out there to do it, but you can actually manage what you've got. So let's talk about the current tools and the solutions that we're looking at. I liked your heading here where you see the hammer screwdriver.
That's exactly it. I was trying to find a nice little quirky, below that you'll see using the right tool for the job.
Yeah.
And that's what we all know and understand. But I think it's very important, because we, in a technology point of view, there are so many different ways to get to one answer, approaching it from so many different ways, but it's not necessarily the best one. We're looking for that efficiency. We're looking for those deliverables that we can trust. So we need to find those right tools.
Yeah.
And this is where something like InfoDrainage would come in, because this is what it was made for. We have the implementation of all of those SUDS elements, like our swales, our bioretentions, our permeable pavings, all of these different design factors that we can use. And this is what the software is there for.
Yeah.
It is allowing us to then start looking at these factors.
Yeah, no, I think that was what really attracted me to the product, and what really got my mind going was that today with all of these products, and we'll show you the breakdown of them just now, but with InfoDrainage, I'm able to replace 5 or 6 different products I was using in the past. I'm able to remove, I don't have to break out to do something different. I don't have to do, go into a piping tool for something else. I don't have to go into something to do this. And I don't have to add a plugin to do that.
Or you have to open up an Excel spreadsheet just to do this one calculation check.
Yeah, it's all in the software. And that to me is really, really the power of the solution. And I think one of the things that Autodesk has been very good at is thinking about not only, just water infrastructure. They think about all of the projects around it. And I think this next slide really captures that. It talks about, where we are and what role we play and which products fit into each of those roles.
Yes.
And I think, and I'll just quickly go through the slide, and Jason, you just jump in at any stage where you think I'm forgetting something. But the way that the solution has been put together is that from every type of person that gets involved in a discussion, whether it be an owner, an engineer, a construction, the handover, the final project, everything has a tool and everything has a workflow and a handover point from it. So for instance, water structures, water networks and treatments, you can see that Autodesk have products and services that fit into every product. So if we do capital planning, we have the tools to do that.
Exactly.
So you
made for that.
Yeah. Exactly. Yeah. So if you wanted to go and take an asphalt product that's already there, a structure that's already there, we have Recap for scanning it. We have InfoWorks for doing your infrastructure design. Yeah. And then you've got ICM, which is going to do your planning and your hydraulic modeling. So there's products that allow you to fit in everywhere, and everything is interoperable.
And that's the thing I love about it the most. From a technical point of view, that's at the moment in the industry is like we've got this massive boom with new technology coming out. But as a technical guy, I need to be able to take information from one point and manipulate the data within all the different aspects. And that's what I love about not just specifically the Autodesk products, but just these products as a whole, is that interoperability, the smooth transition of just taking data from here, putting it over here, and using it in the next design element. And that's another thing that's so underrated at the moment.
Yeah, and I think that's where the work, and we talk about network design, where we talk about Civil 3D, and all of the products where we talk about Civil 3D. The handover between the Autodesk product and the Autodesk water product and the Civil 3D product is completely seamless and bi-directional.
Oh, yes.
So as you're changing something on one side, it's changing on the other, and you're affecting it. You can see cause and effect as you go.
Directly, yeah.
And the beauty of that is everything is then linked together. So whether you're going into the ACC construction cloud and you're going to do construction, or you're moving into handover for operating and maintenance, there is a tool that can support you there.
Yeah, it's fantastic. Yeah, connecting to Info 360 assets, for our SCADA data and stuff like that. So it's just finding where within the workflow are we utilizing the right tool. Yeah. And that's the main thing that we also need to remember, to actually make sure and double check because I do know from personal experience out the industries, what you don't know, you don't know. And unfortunately, you have to take that step and go look, what is there? What is it out there that I don't know about? And that might be the solution that we might be needing.
And of course, and then the big thing that I keep on forgetting about is the integration with ArcGIS.
Oh, definitely.
Taking your scalar data, taking information out of ArcGIS and being able to automatically import it and replicate it in the water technologies is a huge value add.
Oh, definitely. Especially from a design perspective alone. The GIS data that a person has access to these days is phenomenal.
Yeah.
It is pretty much okay, I can't say it with 100% confidence, but it's getting very close to the point where you don't need to actually have a site visit anymore.
Yeah.
The amount of 3D information and visualizations that we can utilize just from the generic data that we're just collecting, it is fantastic. Yeah. And I think a lot of designers these days can't do without it, because a lot of your design decisions come on from those elements of what is happening on site. You might be able to see on a picture that you've got very green vegetation in this area, showing you might have a pipe leak, whether it be stormwater or sewer, but those visuals are what gives you the information just from looking at the ground.
Yeah.
And that allows you to then implement and preemptively plan for possible problems ahead of time.
No, it's very important. And these are things that we're really excited about. But we're not going to talk about everything today. We're going to focus purely on the drainage side.
That's correct.
So give me, before we go into why InfoDrainage, just quickly give us a 30-second, what is InfoDrainage?
Fantastic. So InfoDrainage is a 2D and 1D simulation with regards to anything flood and sewer related. So this is also primarily focused on sustainable drainage, was the main idea with InfoDrainage, but it also just allows us to look at sheet flow and stormwater analysis and hydraulic data. Okay. So that is the main InfoDrainage.
Dumbing it down from here again. So anything you're doing with drainage design, InfoDrainage is a product.
Pretty much, yes. Anything that is overland flow as well as overland into pipes, InfoDrainage.
Okay, cool. And sewage and
flow.
Stormwater.
Correct, yes.
So everything together. So then why do you think that, based on what we've spoken about today, why do you think InfoDrainage is the right product for us to use?
Correct. So the first one being, like you guys can see on screen, is just the connectivity, like I mentioned. The interoperability between Civil 3D, for example, is one of the packages. InfoDrainage can even go through to ICM. The seamless integration, because at this moment, InfoDrainage has a lot better sustainability tools than what Civil 3D does.
Yes.
However, Civil 3D might have a little bit better detailing aspects of it. So we need to have both of those, but we can still complete everything within either. So just being able to, once again, take the information and visualize it with the different software. If you need to maybe just double check an answer that you're not too sure about, but you trust the software a bit better, you can then do that.
Okay. So just one pause there. I see we have some questions. I'm not going to answer them now. We'll leave them to the end. Okay. If anyone's got questions for Jason and I, please feel free to post them in the chat. I promise at the end I'll tell you how to get your discount code, but we will get there.
And we even have that feedback form that they use.
Yeah, the feedback form, guys. Please complete the feedback form. It really helps our team to get that information into the system. And I think I'm getting a coffee for mentioning that.
Ooh,
because the marketing team did bribe us to say please for the feedback.
You did get reminded.
Yeah, so I think it's not an and or an or discussion. It's not an either or. I think it's both. You need Civil 3D and you need InfoDrainage because it gives you that seamless work.
Correct. It makes your life a lot easier. You have the right tools at the right stage.
And while I'm thinking about it, where does that leave SSO?
Wow. Personally, I know I might get a lot of trouble for saying this, but I think SSA is dead. Hey, it was a good starting point for a lot of us being able to efficiently get hydraulic data in. But the support that it's currently receiving, it's not worth it. We've got so many better products that are getting better attention that it's just, it's dying.
Yeah, there's some really cool papers. If anyone asks on the feedback form wants to see it, we've actually got some comparisons between the two and how you can shift your workflows over that. But I think, as they say in Afrikaans,
there we go.
Yeah, that's exactly what's happened. It's just fallen so far behind.
Yeah,
that the technology's just gone ahead of it. And I think, when we talk about this next point around that full site design and analysis, that's where the real sexiness starts coming in.
There we go. Yeah, because that's what a lot of the engineers are looking for. Like you mentioned earlier, we cannot be affording to have 6 different software packages. Firstly, financially, it's not feasible.
Yeah.
The amount of return on investment that you get per product is sometimes not worth it because you're utilizing one product for one function. And it's got all these other cool extras, but I've got other, you've got other software that does it better.
And you know, and then also people say to me, oh, but I can use PC Swim for free. You can, but it's such a ball ache. I mean, the amount of hours you spend working on it, you may as well just do it in the software.
Right. Because what's your time worth at that stage of you sitting for an extra 2 days because it's free?
Yeah. Exactly.
Where we could have the right solution and it's done within 2 hours.
Exactly. And that's where the cloud simulation for me is really becoming very cool. Yeah. So unlimited cloud simulations. Yeah. Leave your computer to run, carry on with your work, upload the data, and off you go.
That's correct. And I think a lot of people, especially from a technical point of view, a lot of people forget actually the amount of intricacy and the quality of those simulations. Yes, firstly, we have the time aspect and all of those things, but I'm sorry, your little i7 16-core little processing laptop versus an entire dedicated server room.
Yeah, it's just not going to keep that.
But it computes it a lot better because it runs multiple iterations over and over to check them. So from a time aspect, yes, it's faster, but just from quality, you can just rely on those answers a lot better and those results for utilization, taking it back into the field.
Yeah, especially, I mean, one of the new things they brought in was the meshing, improved meshing. I mean, that's huge. I mean, being able to do proper meshing on drainage design is going to really help people.
Exactly. And I'm glad to see this is one of the first products that is actually understanding how serious the terrain affects your designs, because that is what everything is based off of. Our calculations are going for sheet flows and using the surface, but we are trying to predict behavior of water relative to that element.
Yeah.
The more accurate and the better we understand that from a software perspective, just allows us to get and replicate the real life results a lot more.
Yeah. And that's where cloud simulation comes in. You can do so much more with it.
And there's
so let's talk about what you say, you're hitting the nail on the head.
Yes. So first off is just going to be our visualizations, as well as the overland flow corridor. So this is where we start looking at the sheet flows.
Okay.
How does the software take that mesh, divide it into the cells, and actually run these computations? So, and then being able to take these numbers and binary values and have a nice little pretty picture that we can give to the stakeholders or back to the clients, so that we can take this analytical answer that we're working with and present it to someone that might not be working with analytics on a day-to-day basis, that is better or more visual person, so that they can understand that a lot better. Then we've got the streamlined design process. So with regards to not InfoDrainage specifically, a lot of the Autodesk products is we've moved away from just having the tools in the software application and more looking at the workflow. This is where we start, this is where we need to be at step B, and this is where we're working towards. And the software is catered over that to a lot more workflow orientated. So the software package has actually been set up in that way with your tabs to go from importation to design, then to export. So the workflow and the user access is a lot more streamlined and easier to use. And sorry,
yes. Yeah, you're talking about intuitive green infrastructure. Now, to me, that's if you wanting to build your green credibility, this is where you do it.
Oh, definitely.
Because this is where you can have the highest return. It's rain, it's everything that you can use. Yeah. So I think having that in it is and I think that the focus that Autodesk has put on this is really good for our customers.
Oh, definitely. And I think this is also going to be a good starting point for many companies as well, that might not have been looking into this and might just be realizing this for the first time. You know, if you need to be learning about this for the first time and getting information about this, this is also a very good starting point, because it covers all elements from A to Z. So you won't be shorted anything throughout this process of, okay, but what is a sub?
Yeah.
What is an LID? You know, and then this will be able to guide you into that. It's like, okay, but this falls in, so we have a better overview of the structural elements and how they fall into one another. So yeah, I think this is a very good starting point for beginners as well.
Okay, and then you talk about phase management optioneering, yeah?
Correct. So this is exactly being able to take your project and start in the beginning where we have the master plan and look at how everything's going to go into that. Then take it one step further into our SUDs. How is each individual element working with one another, and then taking over to the LID to then be able to go look at that specific element. Is that functioning as efficiently as possible? So we can actually
rolling it back to master plan. You want to say, is that functioning, and then run it back and see the impact that you're doing.
That's
Your
correct.
option here.
Yeah, and then actually having those revisions, and then once again, like we said earlier, is not being able to have to start from scratch.
Yeah.
That we have this start point and we're like, okay, only this element needs to change, and then just reviewing it from there until you find the right answer.
Yeah, and your first challenge that you mentioned here about ensuring optimum design, oversizing and undersizing. I was laughing because I had a chat with a customer this week about that, or last week about it, where they were saying, oh, our models are too heavy. We're trying to design too much, but they were using the wrong tools.
Wow.
So they were trying to do everything in Civil 3D. And you just can't. I mean, the tools are there now for you to be able to get you your right size of a project, make sure that you've got all of the data that you need specifically for that project, and then run it through.
Because I think, especially with those guys that mentioned they struggle with a lot of things, many times I actually find a lot of times like, it's your safety factor, something as silly as that, that's like just compounding a safety factor everywhere. And at the end of it, you've got a pipe that's 3 times bigger than what it actually needs to be, you know? So yeah, it's very good that design, and that comes back onto the workflow element of it.
It does very much so. So I'm going to quickly pop onto the questions now and to see what we've got here. And let me, sorry, I clicked the wrong button there. Let me just get back to where we are. And I want to just see. Okay, mainly the comments that we've seen are from our internal guys, which is quite interesting. So guys, on that discussion, there's the feedback form. If you could please complete it.
Yes, please.
Yeah, the feedback form is really valuable to us. And if you do that, we actually have a discount for you guys.
No way.
Yeah, so we've secured a discount that's valid until the 15th of July. That if you've completed the feedback form, you will get emailed a copy of a discount code, and that can be applied on your next Autodesk order with Modena. And it's really only available to people that are on the school, so please don't share it with anyone else. But it's really cool to have that and get that information out there. I'm going to open up the tour just to see if there's any other questions that anyone has. I see the form is there now. It's being promoted by our marketing ladies. I'm not getting any questions. There was one question where Heather Wurstazen said, hello, Jason. Nice to meet you at last.
Hey, Heather. Nice. Glad to see you joined us today. It's fantastic.
Yeah.
It's always so nice to actually have a lot of our clients actually join us and being part of the industry, you know, and actually helping us and getting involved.
Yeah.
I mean, it's one thing, a lot of us sit in our offices and we work in our own environment. And that's one thing I love about actually just working at Modena is I have freedom and flexibility to actually see what is the industry doing as a whole. So being able to have you guys chat with us, it just makes it so much more fun, a lot more enthusiastic, and we learn a lot more as well because we see all of these different viewpoints that a person normally wouldn't actually.
Yeah, that's a very valid point there. And I think, you know, what we're talking about today and why Autodesk Water and why we focus on water so much is that this is the next revolution.
Oh,
it is definitely, you may not see it today, but water is the next electricity for South Africa. We're already seeing it in some regions, but it's the next big challenge that we're going to have to overcome. And software solutions and cloud-based products are going to help us be able to address that as quick as possible.
Yeah.
So not only in design, it's on water utilization. InfoDrainage is an incredibly powerful tool. You know, it does both potable water, it does stormwater, and it does wastewater. So we've got everything in one tool. They have now broken that up into different products. So we've got different focuses to try and drop price points down. As of this sort of week, you can now buy just stormwater if you wanted.
Oh, yes.
Or the other products. So they've actually broken that out. But we'll talk more about that at a later stage. Nadia Patel has asked if we can do one on InfoWater Pro. Absolutely, we can do that for you guys.
Fantastic. Yeah, that's actually a good one because I mean that's now looking at integration directly to ArcGIS. Yeah. So that would actually be quite a fun one because they'll be working in the GIS space again and actually be able to design within that. So
InfoWater Pro is a phenomenal technology. I mean, the fact that you're linking live to your GIS data, you're pulling all of the information through to your model, it's really cool. And yes, absolutely.
Very underrated.
If you'd like to have a session with us, please just put that into the feedback form. We'll actually come and do that for you, or we'll host one if we get a time slot.
Yeah, that's what I was about to say to Nadia as well. Is like, you know, you don't have to wait for the next webinar. Just get in contact with ourselves, get in contact with Simon through the feedback form and stuff like that. And we can even come do a demo for you at your offices. But definitely we'll be looking at doing one of those because it's such a fantastic topic. Yeah.
Jason did some work around gaining water and showed us, he took the Doozy Valley and did some work there. It's really cool.
It's crazy. Yeah.
But guys, thank you so much for joining us today. We really appreciate everyone that was on the call. Don't forget your discount code, complete the form, and you'll get it. And thank you very much for joining us today. Fantastic. Anything else you want to close with?
No, I think that's been great. I was actually hoping for a bit more questions, but we'll just grow these slowly and have some fun with it. But yeah, great having you. Thanks for the chat.
Excellent. Thank you very much, everyone. Cheers.